Okay, today what we're going to discuss is being able to write the rule or the general equation for an arithmetic or geometric sequence. If you remember in the last video, we discussed our ability to be able to recognize if it was in fact an arithmetic or geometric sequence. So let's just recall some of our information. Last video we discussed there are multiple sequences that are out in our real world. Fibonacci, for example. There are multiple different types of sequences, but we're going to focus on two for the rest of this chapter. The two that we're going to focus on is arithmetic sequence and geometric sequence. Now we got to remember an arithmetic sequence has a common difference. A common difference is the variable d, and we can calculate our common difference by taking the second term and subtracting it from the first term, and then continuing on with that pattern, the third term subtracted from the second term, and so forth and so on. The geometric sequence has a common ratio which we call r, that's the variable we're going to use, and my r can be calculated by taking the second term's value and dividing it by the first term's value. Now keep in mind that an arithmetic and geometric sequence, because it has a common difference or a common ratio, there's a general rule that we can use or formula that we can use if we know in fact it's arithmetic. So if it is an arithmetic sequence, you can use the formula a sub n, which represents any term in the sequence, n would be the number of the term, is equal to the first term, which we call a sub 1, plus n minus 1 times d. If it's a geometric sequence, then we can calculate or find answers for geometric sequence problems by using the formula a sub n is equal to the first term times the common ratio raised to the n minus 1 power. So let's take a look more specifically at an arithmetic sequence. An arithmetic sequence has the formula a sub n is equal to the first term plus n minus 1 times d. Now you may need to pause this if you want to copy these notes. A sub n represents any term in the sequence, so the value for any term in the sequence can be found using this formula. The first term, of course, is needed because you have to know where you're starting in the sequence. The number of terms, which if you remember from our last lesson, that's our domain value. So which number we're dealing with in the sequence, if it's the first number, the second number, the third number, so forth, so on. And then d is our common difference. So let's see if we can write a rule using this formula now. There's a series of steps that we're going to go through. So take a look at problem number 1. It says write the rule or the equation for the sequence 9, 10, 11, and 12. And if this sequence was to go on forever, we could still use this equation to represent every term in this sequence. So the first thing we need to determine is this arithmetic or geometric? Well, I think by observation you can see that this is in fact arithmetic. If I add 1 to 9, I get 10, so forth and so on. But if I wanted to formally calculate it, I would say my common difference is the second term minus the first term, which is going to be 10 minus 9, which is 1. So my common difference is 1. Now what I need to do is to identify key terms for the sequence, meaning that I want to pull out information from this sequence that will match the formula that we're using up here. So let's see if we can do that. Obviously a sub 1 would be 9 because that's the first term of my sequence. Okay? How many terms I have? Well, remember, since this can go on forever and ever and ever, we really don't know what the n value is. So the question is, can I calculate any term in the sequence using a formula? So here's what I'm going to write. Any term in the sequence is equal to the first term plus n minus 1 times d. I know what the first term is. It's 9. So I'm going to place 9 right here. I don't know how many terms I have. And my common difference is 1, which we found right here. Now, doing the simple algebra, distributing the 1, and cleaning this up, I end up with n plus 8 as my rule that would represent any term in this sequence. Let me slide that up so you can see it. N plus 8 would be the formula that I would use to calculate any term in this sequence. Now let's take a look and see if that works. That's step number 4, a quick test. If n equals 1, then I simply put in 1 for n, and I end up with 1 plus 8, and that is 9. That's exactly what the first number in my sequence was. If n equals 2, I end up with 2 plus 8, which is 10, and that's exactly what the second number in my sequence was. And as you can see, if I continue this on for any values of n, then I would end up with, in fact, this sequence here. So let's do a little bit of practice very quickly on arithmetic sequences. Let's take a look at example number 2 here, and we're going to walk through our process again. Step number 1 was to determine, is it arithmetic or geometric? Well, as you can see, my common difference is going to end up being negative 40, minus negative 20. Subtracting a negative, we're going to add the opposite. So we're going to get negative 40 plus 20, which is negative 20. So this is, in fact, an arithmetic sequence, because it's very easy for me to see that if I continue to subtract 20, I'll end up with my other terms. Okay, now what I need to do is pull out key information. Well, my common difference is negative 20. My first term is negative 20. It just happens to work out that way for this problem. And so using my formula now, a sub n is equal to the first term plus m minus 1 times d. I substitute in my first term, negative 20. Again, I don't know how many terms I have. My common difference is negative 20. Working the math and distributing the negative 20, I come up with the conclusion of negative 20n. Now the assignment that you're going to have on IXL, you'll be required to type that in for your answer, negative 20n. A quick test will show that this does in fact work. If I use n equals 1, then I'll end up with negative 20 times 1, which in fact is negative 20. N equals 2, I end up with negative 20 times 2, which is negative 40. As you can see, I'm starting to repeat the sequence. So this would be the general rule that I would use to calculate my arithmetic sequence general rule. One more example, a little bit different numbers. Once again, is this arithmetic or geometric? I think by inspection you can see that I am increasing by 6. 7 plus 6 is 13. 13 plus 6 is 19. 19 plus 6 is 25. So this is in fact an arithmetic sequence. My common difference is the second term minus the first term, which in this case is 13 minus 7, which is 6. And I could carry this out through the rest of my terms. My first term's value is 7. So the formula that I'm going to use then, again, the first term plus n minus 1 times d, plugging in 7 for my first term, and then n minus 1 times d, which in this case is 6. Then I clean this up doing the math. 7 minus 6 is 1, and I end up with 6n plus 1, and that becomes my general rule for my equation, or my equation. If I quickly now check if n equals 1, again, whenever you're trying to identify if it works or not, your term values always start with 1. 1, 2, 3, 4, and you just go up from there. So we're going to start n equals 1. We're going to get 6 times 1 plus 1, which is going to give me 7. If n equals 2, we're going to get 6 times 2 plus 1, which is equal to 13. As you can see, we are in fact repeating this particular sequence. So you can calculate the rule or figure out the rule for an arithmetic sequence by using the formula a sub n is equal to the first term plus n minus 1 times d.